Hi everyone, I'm Raghav, and in this video we will discuss the first four problems of Codechef Div 2 contest. So this is the very first problem, Equate S and T. The problem says that you would be given two strings S and T. The string S will have a length of n and the string T will have a length of m. Now the constraints on n and m can be pretty huge. So let's say you are being given a string like A, B, A, B, B. Let's say this is a string you have for S, and for T, let's say you have a string AA. Then what you can do is you can apply some operations on. There is a specific kind of operation that you can apply on either the string S or the string T. What happens in the operation is whatever character you choose, like in the string, you can choose any of the A's. So let's say I chose this A, and then I can replace this A with AB. So the string which earlier looked like AB, ABB will now look like AB, ABBB, right? At the place of an A which lied here, now I have an AB. So I can apply this kind of an operation, and please notice that I can only choose A, I cannot choose B. So in the operation, I can just convert an A into AB, which is sort of equivalent to saying that I can insert a B character on the right hand side of an A. So wherever I see an A, I can just insert a B character on the right hand side of it. I can just say that this is equivalent to the operation which we can apply. So our goal here is we have the strings S and T. We can apply the operations on any one of them any number of times, and we want to make both of these strings equal to each other. So this is the problem, and in the problem it says, like, it clearly states that uh, wait yeah, it clearly states that we can apply as many operations as we want. And okay, I think that they have not mentioned that we don't have to minimize it, but yeah, it's obvious that we don't really want to minimize the number of operations. In fact, we don't even have to tell the number of operations. We just have to tell if it is possible to make both these strings equal or not. So let's take an example. If you had the strings as AB, ABB, if let's say string S is AB, ABB, and the string T is ABB, AB, ABB, AB. In that case, you see, here you are having AB, and at the same place in the string T, you are having two B's on the right hand side of A. So obviously you would like to replace this A with AB, Hana. So let's do this. You would choose this A, and the string would now become AB and all the things which you earlier had, that is ABB. Yeah, there was a B as well. So basically the string now became A double B, A double B. And if you compare the string S and T now you see initial part is same, ABB, ABB. But after that you are having only AB here and you are having ABB here. So again, this is quite intuitive that you would like to choose this A and transform this string into ABB, AB and B. Hana. You would like to switch this A into AB. So now the two strings you have are ABB, ABB and ABB, ABB, which are both equal. So in this way you could make S and T equal. So you would say yes, right? So our answer should be either yes or no, depending upon whether we can make both the strings equal or not. Now let's talk about the obvious part. Like, what should come in your mind just after reading the problem and looking at the sample test case? Um, in the like whatever string you choose, you would convert an AB in, sorry, an a character A into a character into the characters AB, है ना? So the count of A would remain same and the count of B would be incremented, right? This should come in your mind that in the operation you are increasing the length of the string, you are increasing the number of B's in the string, and you are still having the same number of A's in the string. So um, whatever string S and T I have been given, I can obviously just directly uh, directly say no for all the strings in which count of A in the string S is not equal to the count of A in string T, right? If the count of the character A is not equal in the strings S and T, then I can directly say that the answer is no, because I cannot alter the frequency of the character A by applying the operation. As for the character B, now when you look at the string which you had S, you would have some B's initially, then you would have some B's after the first character, then after second character, after third character, and so on, right? Like after every A, you would have some B's and you would have some B's initially as well. Similarly, in the string T as well, you can apply an operation by choosing an A and increasing the frequency of B, which is coming between the A which you chose and the next occurrence of A, right? So can I say that if, let's say, 7, like B was coming 7 times after the second occurrence of A and it was coming only 3 times after the second occurrence of A in the string T, then I can apply the operation on this A 4 times. I can choose this A 4 times while applying the operation and make this frequency of B 7 between these two occurrences of A, so that it becomes equal to what was there in the string S, so that string S and string T can at least be equal in this part, है ना? And I can similarly make these occurrences of B's equal as well, similarly for these occurrences, and so on. So yeah, I can just make all these occurrences of B equal by applying some operations on either the string S or string T. But for these B's, I can't really do anything, है ना? I can't really do anything for these B's. Let's say if B is coming up 2 times here and B comes 3 times here, then I can't really do anything by any means by applying any operations. In this case, the answer would be straight away no. So what we have noticed till now is the count of A should be same, should be equal in both string S and T, and the count of B in prefixes of the string S and T should also be same. Basically, the number of B's coming before the first occurrence of A, है ना? You can't change their count, so they should also be the same. So we have these two conditions. If both of these conditions are fulfilled, it means that you would have, let's say, same number of B's initially and then you have same number of A's here. Then in that case, you can automatically uh, just apply some operations and make the frequencies of B's equal, and you would be able to make both these strings equal. So we can say that if both of these conditions are true, then the answer is yes. And if any one of these is false, you can't really alter it. So the answer would be no in that case. So all we have to do is just find out these two things: count of A in the complete string and the count of B before the first occurrence of A. And these things should be equal. I hope this problem is clear. Let's look at the code. So in the code, for each and every test case, I'm first of all taking the inputs. After that, I'm finding out the number of B's in the prefix before any occurrence of A. After that, I'm finding out the number of times A is coming up in the string. And then I'm just checking that if both of these things are equal, then the answer is yes. Otherwise, the answer is no. So that's it for this problem. And the time complexity here would be big O of n, because we are just iterating over the string. We are not having anything else. So the time complexity can be written as big O of n plus m, and the space here is also big O of n plus m for each and every test case, and the sum of n and m over all the test cases won't exceed 2e5. So the time complexity, basically the number of iterations overall, should be around 2 into 10 raised to the power 5, which is good enough. So let's move on to the second problem, which says that there is a shop with n distinct items numbered from 1 to n. There is also a Boolean array B of length n. You want to buy all the n items once each in some order. So we can say it as P1, P2 till Pn. When buying the item Pi, if B of Pi is equal to 1, in that case, if BPI is 1 and there exists some j less than I such that Pj is greater than Pi, then you will get 2 copies of Pi. Otherwise, you will get only 1 copy of Pi. Informally, again, this was the formal thing. Now, informally, you can say that you will get 2 copies if you have already bought an item with a larger index before. Otherwise, you will get only 1 copy. And if BP of I is 0, you would get 2 copies if you have bought an item with a smaller index before. Otherwise, you will get 1 copy. We have to find the maximum number of items that you can have at the end. Basically, if you are getting 2 copies for something, you would consider it as 2 items, and we have to find out the maximum number of items that we can get. So let me explain the problem here as well. There are n items in a store numbered from 1 to n, and you have to buy each and every item in some order, and you have to buy each and every item exactly once. So let's say the order in which you buy the items is P1, P2, P3 till Pn. It can be anything. It is this P array would be a permutation of the first n natural numbers. So each and every natural number from 1 to n would come exactly once in the permutation. Now we have been told that if BPI is equal to 1, like we are being given an array B as well of length n. So let's say you were about to buy the P1 item first. Okay, I think instead of thinking about P1, P2, P3, it would be better to take some numbers instead. Let's say n is 5. There are 5 items and you decided to buy the items in the order 1, 2, 3, 4, 5. We are keeping 1, 2, 3, 4, 5 for simplicity. Sorry. Okay, so we would be given an array B. Now what would happen is, let's say you are about to buy the first item. Okay, like you have decided the order in which you will buy the items, so you would go one by one to all these items. Now if you are about to buy the item 1, you would go and check B of 1 in the array. Like you would check what is there at the place B1. Now if at the place B1, basically at the position 1 in the array B, if there is a 1 and if there is a 0, and in the order in which you are about to buy the items, if on the left hand side there is any element which is smaller than 1, then you would get 2 copies of the you would get 2 copies for this item. Otherwise you will get only 1 copy for the item. So in this case, on the left side of 1, like before 1, you didn't buy anything, so obviously there is no item with a smaller value which you would have already bought. So nothing will happen here. Now you would go to buy two. Like in this, for the case of one, you got only one copy as you didn't have the condition being fulfilled for getting two copies. Now for 2, let's say B2 is also 0, then what you would do is you would check on the left hand side, like the items which you have already bought before 2, is there any item which is having a smaller index than 2, a smaller value than 2 maybe. And yeah, there is an item 1 which you bought, so it is smaller than item 2, and B2 is 0, so you would buy two items for you would buy two of these items. You would buy two copies for this. Now for, let's say, the third index, the third item, let's say B3 is 1. So for B3 you would check on the left, like the items which you have already bought. Is there any item which you have bought and it is having greater than 3, the value of that item being greater than 3? So in this case we don't have any item, है ना, like that. So you would buy only one copy for 3, and I hope you got the idea. So if you had bought these items in, like, let's say this order 2 4 3 1 5, let's say this was the order in which you bought the items, and the given array B, like B would be given to you. Let's say if this array is something like 0 0 1 1 0, this would be a binary array. So you would go to buy these items in this order from, like, whatever order you have chosen in the array P. You would go to buy 2, then 4, then 3, then 1, then 5. When you go to buy 2, like this one, uh, you would check that what is there at the place B2. You have a 0. Then on the left hand side you don't have any smaller value than 2, so you would buy one copy for this. Then you would go to 4 and do the same thing again. Go and check for 4. 4 has 1 here. So do you have any larger value on the left hand side of 4? No, you don't have any larger value. Yeah, here B4 was equal to 1, so that is why we are checking for a larger value on the left hand side. You don't have anything, so you would buy only one copy of this as well. Then for 3, you go and check in the array. It says 1 here, right? So you would check on the left hand side if there is any larger value than 3 in the array before 3. So yeah, there it is. We have a 4, we have bought the item 4 before 3, which is greater than 3, so we will buy two items of 3. Then you would check for the item 1, like for item 1 here B1 is 0, so you would check on the left hand side if there is anything smaller than 1, and there is nothing smaller than 1, so you won't buy two copies and you will buy only one copy. Then you would check for 5. For 5 you have B5 equal to 0 here, so check on the left hand side, is there anything smaller than 5 available on the left hand side? Yeah, there are more than one. Actually there are all these 4 smaller than 5, so you will buy two copies of 5 as well. So for 2 we bought 1, for 4 we bought 1, for 3 we bought 2, for 1 we had bought 1, and for 5 we had bought 2. So we actually got like 7 copies. Now in the problem you would be given this array B. You would uh, yeah, you would be given only this array B. You are not being given this array P. You have to tell what is the maximum number of copies you can buy, considering that you can choose any permutation of your choice. You don't have to print the permutation, you just have to tell what is the maximum answer you can get if you could choose any permutation. So yeah, I hope the problem is clear. Now, as soon as I had read the problem, the idea which I had got just after reading the problem was that if I keep the first guy in the permutation as 1 and the second guy in the permutation as n, the largest guy, or the other way around, keeping p1 equal to n and p2 equal to 1. If I do either one of these things, then in that case, whatever elements, whatever items I buy after buying these two things, I would definitely get 2 copies, no matter whether b2 is equal to 0 or b2 equal to 1. Or here you have b2, other than b2, if you have b7, b8, b5, anything, you have already bought the smallest and the largest guy. So for everyone after these two people, you would definitely buy 2 copies for them. This was the first idea I got just after reading the problem and understanding what we are doing. So the first thing, the first intuition is that since you want to buy maximum number of copies, as many as you can, you would like to think of a way in which you could secure that I won't have to think much and I would be able to buy 2 copies for almost everyone. Hana, this was the main intuition part from where we got the idea that maybe just buy the smallest and the largest item first, the item 1 and item n directly. After that, I would buy 2 copies for everyone. Right. Okay. Now the thing is, should I buy in this order or in this order? So let's think about it. Let's say b1 is equal, okay, you have uh for any, okay, you would be given this array b1, b2, b3 till bn, है ना? So for anyone between b2 to b of n minus 1, it doesn't matter whether these values are 0 or 1 because they will definitely get 2 copies. Our uh, point of concern is this only. What are the values of b1 and bn? Does it matter or not? है ना? We want to check for them. So you would check for b1 and bn. What are the possible combinations? There are these 4 possible combinations which can happen. So if b1 is 0, it means that whenever you buy the item 1, you would want that on the left hand side there should be a smaller value than b1, sorry, the smaller value than 1, and which is never possible. 1 is the smallest guy himself. So in this kind of case, it makes sense to buy the item 1 first, right? If you have b1 is 0 and bn as 0 as well, you would like to buy the item 1 first and then you will buy the item n. So when you buy the item n, you will get 2 copies here because bn is also 0. So on the left hand side, you would find a smaller value. And when b1, like for b1, obviously you could not get more than 1 copy. And for everyone else, you are getting 2 copies each. So overall, you got 2n minus 1 number of copies in this way. Nextly, if b1 is 0 and bn is 1, in that case, for b1 you want a smaller value on the left, and for the item n you want a larger value on the left. Both of these things are not possible. So no matter whether you place them as 1n or n1, for both the items you will buy only 1 copy. So overall you are buying 2n minus 2 copies in total. 2 copies for everyone else other than these two, and for these two we are buying 1 copy. So there is a total of 2n minus 2 copies which you would buy. For the case 1 0, you can simply place them as 1n or n1. It doesn't matter because in both the cases the first guy will get only 1 copy, which is obvious because this is the first item you are buying now. So you can never have anyone on the left hand side which is smaller or larger than you. So you would buy only 1 copy for the first guy, and for the second guy, if you are buying in the order 1n, then you are having 2 copies for this because there is a smaller element on the left. And if you're buying in the order n1, then also you are getting 2 copies for the second guy and 1 copy for the first guy. So overall you got 2n minus 1 copies in this case as well for the complete array. So 2n copies, 2n minus 1 copies, 2n minus 1 copies, 2n minus 2 copies here. And for this case as well, um, you can buy in the order n1, like buy the item n first, then buy the item 1, and then you can buy anything. So you will get 1 copy here, 2 copies here, and 2 copies for everyone else as well, which sums up to 2n minus 1. So I hope we can at least conclude that if you're having b1 equal to 0 and bn equal to 1, in that case you are getting 2n minus 2 copies, otherwise you are always getting 2n minus 1 copies with the strategy which we had applied of picking up 0 and 1 and n at the first two places. So with our strategy, what we can do is, first of all, take the array b as input. After that, check if b1 equal to 0 and bn equal to 1. If this is the case, then the answer is 2n minus 2. Otherwise, the answer is 2n minus 1 according to the strategy which we have got till now. Now, right after this, once you would have got these two solutions, basically we have formulated our approach, you would now try to think, can you have a better answer with some other approach? Can you get more than 2n minus 1 copies? Like, we are doing this part just for making sure that we have actually got the best possible solution. So you would like to prove it. So the thing is, currently with our approach, we are able to get like 2n minus 1 copies. If you want to get more copies, the only possibility is 2n. If you get 2 copies for everyone, which is completely impossible, because for the first guy, whoever you buy, like whichever item you buy first, there is nothing on the left hand side which is greater or smaller than this. So you would definitely get only 1 copy for this. So the maximum you can get is definitely 2n minus 1. You can never get 2n copies. So yeah, you can never have more than 2n minus 1 copies. Talking about the case where our answer was coming up to be 2n minus 2, here in this case, b1 is 0. So no matter when you buy the item 1, wherever you buy the item 1, on the left hand side, there will never be any there will never be any item with a value smaller than 1. So obviously you will buy only 1 copy here. Similarly, bn is 1. So whenever you, like, it doesn't matter whenever you buy whenever you buy the item n, on the left hand side, there will be no item with a larger value. So we can clearly say that in this case, the maximum possible answer is 2n minus 2 only. We can never get a better answer. So when you have done this much, it is easy to say that we have got our answer. So this problem has a very small code. Just take the inputs, then check the value of a0 and an minus 1. Like in the explanation, we used the numbers 1 and n, but in C++ we have zero based indexing, so that is why I am calling them as a0 and a of n minus 1. If these two are 0 and 1, in that case print 2 into n minus 2, otherwise print 2 into n minus 1. That's it. So I hope this problem is clear. The time complexity here would be big O of n, because we are creating a vector and taking the inputs, and the space complexity would also be big O of n, because we have created this array. But we don't really need to create an array. We can actually optimize this to big O of 1 time complexity by just taking these inputs and storing only the first and the last value. But in comparative programming, it's okay. Like, you don't really have to write the most optimal solution. You just have to write a good enough solution to pass within the time constraints. So this is fine. Okay, so let's look at the third problem. The third problem is a good one. This is an enjoyable problem. The problem says that we have been given a string s of length n, and we want to make this string s become a palindrome. To make it a palindrome, we can apply a kind of operation on this as many times as we want. In one operation, we have to choose a substring from the given string such that this is not a full string, not the full string. Basically, if you had the string as ABCD, then you can choose a substring like AB or ABC or BCD or something, but you cannot choose ABCD completely. And the second condition is that it should not be a palindrome. The substring which you choose should not be a palindrome. So these two conditions should be satisfied for the substring we choose. And once we have chosen such a substring, we can just delete it. So let's say if you had a substring, you had a string like A, B, C, D, E, F, G, H, and I choose the substring D, E, F, which is not a palindrome, it is not equal to the complete string. So I have full right of deleting this. And then the new, like the new array after deletion would be A, B, C, G, H. And I can just do this kind of operation as many times as I want. The main idea is I just want to make it a palindrome. And there is one more thing. The problem is asking us to find out the minimum number of operations. So even though we can apply as many operations as we want for making it a palindrome, there is no upper limit, but we have to find out what is the minimum number of operations that we must apply for making the string become a palindrome. And in case if the string can't become a palindrome with this operation, then we have to return -1. So in this problem, the constraints are pretty decent. N would be less than equal to 2e5, and the sample test cases are very good. The first one is race car. This is already a palindrome. Yeah, palindrome. So the answer here is 0, of course. You don't need to do anything. If the given string is already a palindrome, this is already good enough. The second example they have given is having two characters, both distinct. So in this case, neither you can delete this y nor you can delete m, and obviously you cannot delete the complete string either. So you can't delete anything from this string. So you won't be able to make it a palindrome. So the answer is -1 here. For the case not possible. And the third example is having something like modem, which can become a palindrome in just one operation, as you can delete OD here. According to the example, you can delete OD from it so that you have only MEM left. But from this example, you could have noticed that what if I just delete this whole thing? I just delete ODEM completely and I will have only M left, which would obviously be a palindrome. Hana. What if I only keep the first character and delete everything? Then in that case, I would be left up with just one character, which would be a palindrome for sure. And maybe this part is like, it is possible that you have a string like MEE where you can't delete the last n-1 characters as they are forming a palindrome. So in that case, maybe just delete the first n-1 characters. So in that case, like MEE, you could just delete the first two characters and you would be left up with just one character, which would be a palindrome. So yeah, this is giving us a good idea that what if I just delete n-1 characters from first or the end. But obviously this thing, there is no guarantee if it would always work or not. Like in this case, it won't work because The first n minus 1 character and the last n minus 1 character are both palindromes. है ना? So let's just try to have a look at what will happen when when can we not apply that idea of ours. Let's say there are 6 characters in a string and the first 5 characters are forming a palindrome and the last 5 characters are also forming a palindrome. So it means that whatever was the first character would come as the last second character as well. Similarly, whatever character was coming up at the last position would come at the second position as well. Now, since this is a palindrome, and now this is a palindrome we already know, otherwise we would have been able to make this string a palindrome in just one operation. So whatever comes at the second position would come at the last second position as well for the palindrome. So B must come here as well. And similarly for this palindrome, A is coming up here at the last second position. So it would come at the second position as well. Which means that this must be the string you have, and I think you would have got a general idea that whatever string I had, let's say if the string was of even length, the first n minus 1 and the last n minus 1 characters were palindromes, then that substring would be alternating substring a b a b a b a b, or it would be a sorry, that string, complete string would either be something like a b a b a b a b, or it would be like a, all the characters being equal. That is also possible. If all the characters are equal, then this is this case, that the given string is a palindrome. So obviously as soon as you take a string as input, you can just check if it is a palindrome or not, है ना? If it is a palindrome, just straight away return 0. So obviously if you are coming up till this place, you are checking whether the given string is uh, like this or not. So in that case, this case is not gonna happen. Otherwise, you would have already returned 0. So let's have our focus on this case. What if this is an alternating string? Then you can't remove the first character or any character from it, or you can't remove any substring of length 3, as all the substrings of length 3 would also be palindromes. Similarly, all the substrings of length 5 would also be palindrome. Sorry, the substrings of length 5 would also be palindrome, and so on. All the even length, sorry, all the odd length substrings would be palindromes. Right. Which means that we can't delete an odd length substring from this kind of a string. We can only delete even length substrings, but deleting an even length substring won't do much for us, because eventually we would be left up with only two distinct characters, for which we know that the answer is not possible. So basically, long story short, for this kind of a substring, for this kind of a string, the answer would be -1. Right. So we can actually generalize this idea. Like we have got 3 cases till now. The first one is that the given string is already a palindrome, directly return 0. What if it is not a palindrome? Then just check if the given string is something like AB, 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 or AB or not. If it is like this, then the answer is -1. Otherwise, you can either delete the first n minus 1 characters or the last n minus 1 characters, and you would be left up with only one character left, and thus you can make the given string a palindrome in just one operation. So we have encountered 3 cases like this. And there is one more thing. We did consider this case where we had even number of characters. Let's consider the case if there are odd number of characters as well. Let's say there is a string with odd number of characters, such that the last four and the first four characters form a palindrome, then it means that if the first character is A, then the last second character would also be A, and if the last character is B, then this character should be B. So since we are assuming that this is a palindrome and this is a palindrome, you won't you would have to have this character being equal to B for having this as a palindrome, and you would require this character being equal to A for having this as a palindrome. Basically, there is a contradiction. It requires A and B both values at this place. So I was just showing you of what you should have thought, and you would have realized that the problem, like the possibility which we were thinking about, that what if we can't remove the first n minus 1 characters, and we can't remove the first last n minus 1 characters either. This thing would happen only when the given string is having the length even, and the string would look like this, or would look like this case, but we would have already taken care of that. So we would just consider this case for now, and in this case we would return -1. Otherwise you can just straight away return 1 for all the possible strings. So the answer now is really simple. What we have formulated now is, you will just first of all take the string as input, then you will check if it is palindrome or not. If it is palindrome, then return 0. If it is not palindrome, in that case check alternating, if this is alternating or not. If this is alternating, then return -1, else return 1. Because you can just delete the first n minus 1 or last n minus 1 characters, and you would be end up with uh, a string having only one character, which would be a palindrome. So this third problem was actually interesting. I like to solve the problem, and I hope you also did enjoy solving the problem. So let me show you the code. First of all, I took the inputs. Then I checked if the string is a palindrome or not. If it is a palindrome, return 0. After that, I assumed that the string would be an alternating substring and alternating string. And if it is not an alternating string, basically this condition would fail if this is not an alternating string. Then I would make the value of answer become equal to 1 and break, and then I will print the answer. So the way in which I have written this code might not look natural to many, but I was just willing to not introduce any extra variables and write a shorter code. That's why I wrote it like this. So yeah, let's look at the time. Yeah, the time and space complexities are both big of n, because we are just iterating over the array for every test case, and the sum of n overall test cases is 2e5, so this should easily pass. So now let's move on to the fourth problem. This is the fourth problem, buying order hard. This is the harder version of the problem buying order. We had solved the easier version as the second problem of Dev 2 contest. So the problem told us that there are n items. There are n items that we have to buy in any order, and every item should be bought exactly once. And for each and every item, there can be two things. We would be given an array B. Now for the item I, Bi can either be 1 or it can be 0. If Bi is 1 and among the items which we bought before the current item, if we have already bought any item J, um, or maybe we can take it in a simpler way, that let's say if I had 5 items 1 2 3 4 5 and B3 is 1, and let's say I bought the item 3 on the fourth place. So if I have bought any item before this item 3 such that any item j such that j is greater than I, where I is 3, and pj is less than pi, which means that any item before 3 and the item is having a value a larger index than 3, then in that case I will buy 2 copies of this item, otherwise I will buy 1 copy of this item. And in the second problem I wanted to maximize the copies I buy. In this problem I want to minimize the copies I buy. So I'm not explaining the problem statement as I explained in the second problem, because we have already discussed the easier version of the problem. So I'm assuming that you already know about the problem properly while coming to this problem. So if we had something like 4 5 1 4 3 2, then you will get 2 copies here, because for 3 on the left hand side there are 2 people um, who are having larger value than 3. Even if there was only one guy, it would be fine. You would get 2 copies even in that case. So our goal is to find the minimum copies you need to buy And there is one more thing. Let's say if the given array B was 11001, which means that there are five different items, and the values for those items in the array B are 11001. Then you have to find out the answer for what if the array B was only one, there was only one item having value 1. What if there were two items having value 1 1? What if there were three items having values 110, then four items having 1100, and so on? You have to do it for basically each and every prefix of the array B. And that's it. So let's take an example. If you have an array like 0 1, here n is 2, and the array B is 0 comma 1, it means that if you buy any item smaller than 1 before 1, then you will get two copies. Otherwise, you will get only one copy. Similarly, for the second item, if you buy any item with a larger value before 2, then you will get two copies. Otherwise, you will get one copy. So basically, you can't get two copies even if you want. You will get only one copy each time. So no matter in which way you buy, whether you buy the two items as 1 2 or 2 1, you will get only two copies in this case. And let's consider the second case where you have second example where you have n equal to 2 and the array B as 1 comma 1. So in this case, if you buy the items as 1 comma 2, or if you buy the items as 2 comma 1, it now matters, because if you buy the items as 1 comma 2, you get one copy for the first time because there is no one greater than 1 on the left side. Then again you get one copy because there is no one greater than 2 on the left side. But on the other case, if you buy 2 first, you will get one copy because there is no one greater than 2 on the left side. And then you will get two copies because you have someone greater than 1 on the left side. है ना? So you will get three copies in this case and two copies in this case. This one is definitely better. So you got an idea. Like you can at least get an intuition that what if the array B contained only ones. In that case, it would be better to to buy the items in ascending order, to make sure that for each and every person there is nobody greater than it on the left side. Similarly, if all the elements in the array B are 0, then you would like to buy the items in the descending order, because you want to make sure that for every person on the left hand side there should be no smaller value than that. है ना? So these are two very trivial cases. You should definitely think about such things when you are not able to get some very solid intuition for solving the problem. Then just try to think about the simple cases, that what if input was having only zeros, or if it was having only ones, or if it was having alternating 0 1 0 1 0 1, something like that. You can consider this case as well, that what if array B was having only zeros and ones. Then in that case, you would like to buy the item 1 3 and 5 in the descending order, and you would like to buy the item 2 4 and 6 in the ascending order. You know, you would like to buy in this way. Let me just color the ones with green and the zeros with red. Okay, so all these zeros would be colored with red and the ones would be colored with green. So you have like you want to find out a permutation such that so you would like naturally intend to have a permutation in which both these orders are maintained. So you can just think about some simple stuff like placing 5 3 1 first and then placing 2 4 6 after that, or buying the items 2 4 6 first and then buying the items 5 3 1 in these orders. First buy 5, then 3, then 1, then 2, then 4, then 6. So if you do in this way, you will get one copy for the first few people. Then for 2, you have someone greater than 2 on the left side. You will get 2 copies here. Then for 4 as well, you will get 2 copies. Then for 6 as well, you will get 1 copy for 6 because there is no one greater than 8 on the left side. As in the case if you had placed greens first, then you will get one copy for the greens as they are having a good order. But for 5, there is someone smaller than it on the left side, so you will get 2 copies here. Then for 3 as well, you will get 2 copies. Then for 1, you will get only 1 copy. So in both these cases, you are getting 8 copies, है ना? So this is a natural thing which can come up in your mind, that maybe I can have this kind of a permutation. So yeah, this is at least a good start. Now we need to see if this would always work or not. Obviously, proving it to be the best solution might be very difficult or might not even be feasible. So in contests, you would generally try to just think about a counter test case where this will fail. And if you are not able to think about a counter test case, then generally you would just start to believe that this might be true. This approach might be correct. So I did think about multiple cases and I did realize one thing, that whatever like whether the red ones or the green ones, whichever you placed first would always get one copy each because you are placing them in the correct order. After that, when you are placing the other people, like the green ones here, which were having the ones in the original array, in the array B, then you might get some twos and you might get some one copies, like two copies and one copies, depending upon the like in this case, when you are having the greens come later on, if there is any guy greater than the smallest guy of green here, then you will definitely get two copies here, right? Basically, if a green guy is sorry, basically if you are having a red guy being placed first and a green guy being placed second, or even in the other order, if a red guy is being placed second and the green guy is placed first, and the value of the green guy is less than the value which the red guy has, in that case you will always have the second guy always buying two cards. Like in this case, if red is coming first and green is coming second and green is a smaller value, then green will have to buy two cards because green is having one in the original array. As for the other case, if green guy came first and then the red guy came second, then red will also buy then red will buy two copies and green will buy one copy because red will buy two copies if somebody smaller than it comes on the left side. So basically in both these orders, you will get two copies being bought by someone, which was a sign to me that not everybody can be satisfied at the same time. Some people may have some people will definitely have problems. And so here is a recap of the discussion till now. For the problem, we have been given an items. For each and every item you have a value associated with it. In the array B, it is either 0 or 1. either 0 or 1. If it is 1, in that case you will pick up two copies if you pick up any item before it with a larger index. If bi is 0, then you would pick up two copies of that item if you have picked up any smaller index item before the current item, and otherwise you will just pick up one copy. So we want to pick up minimum number of copies, and that is our goal. And whatever array we have been given, we have to find out the answer for each and every prefix of that array, not just for the complete array. But for simplicity, while thinking about the approach, we will uh, find out the answer for only the complete array, just for making the problem a little simpler for us, at least while solving, thinking about the solution. Then we did look at the sample test cases. After that, we try to think about the simplest possible case, that either you will have all ones in the given array or you will have all zeros in the given array. So these were the simplest ways to think, that how, like, where we will decide in which order we should pick up the elements. Then we did think about a case where we were having alternative zeros and ones in the given array. So to make the explanation a little simpler for me while explaining, I associated the red color with 0 and green color with 1, so that I can just call these items as the red items and these items as the green items. So we did have an intuition that we would like to preserve their order, like in whichever uh, way I decide to purchase those items, I would definitely try to make sure that like uh, I persist, like in whichever way I decide to buy the items, I would try to make sure that their order remains the same for these items. And after that, as we had noticed that we were having some people who had to buy two copies. So this problem was being caused because the maximum of red maximum of the red items was actually greater than the minimum of green items, है ना? The maximum of red was actually greater than the minimum of green. So if you place them, like the red item comes first, like in this case, then this green item would be bad, because for the green item you're having a larger value come before it, so you will have to buy two copies here. Or if you had placed the green items first, then for the red item which was greater, you would have to buy two items because you are having a smaller item come before it, है ना? So you can definitely say that if you are having a red item and a green item, and the red item is having a larger value, then you will definitely have at least one of the copies to buy extra item. Okay. So for now, what we can do is, we can just consider that out of these n items, we will choose some subset of these items. We will choose some subset of these items such that this condition is not true. Basically, the maximum of red should be less than the minimum of green. If this condition is being satisfied, it means that you would be able to buy all those items in one, like you would be able to buy one copy for all these items, है ना? Let's consider a case like uh, the red items are 1 2 3. Let's say the red items are 1 2 3 and the green items are 4 5 6. So you can buy them in the order as maybe 3 2 1 4, 5, 6. So you would be able to buy one copy for each and every one of them. For 3, there is nobody smaller than it on the left. For 2, there is nobody smaller than it on the left. For 1 as well, nobody smaller than it on the left. Then for 4, 5, and 6, there is nobody greater than them on the left. So you would buy one copy for each and every one of them, right? This was the main idea, that we would try to choose as large of a subset as we can, such that the largest of the reds is smaller than the minimum of the greens, so that like if you were able to find a subset of length k, like you would be given some array like this one, you would have an array like this one. So if from this you are able to choose, let's say, k elements, such that the largest of the reds is smaller than the smallest of the greens, then in that case, for all of these k items, you would have to buy only k, uh, yeah, you will have to buy only k copies. And for the remaining n minus k items, you will have to buy two copies each. So you will have to buy 2 into n minus k copies there. So the total number of copies you will have to buy is k plus 2 into n minus k, which is nothing but n minus k, 2 n minus k actually. It is nothing but 2 into n minus k. So you just have to find out the largest possible subset, the size of the largest possible subset k, for which you are able to have this condition being satisfied, that the maximum element of the red should be smaller than the minimum of the greens. And for that thing, just look at this given array b, which was being given to us here. These values of items are already sorted, for the item 5, its bi value is given on the 5th position. For the item 3, its uh, value is given on the 3rd position, and so on. So you just want to make sure that the rightmost 0 you pick up should be uh, the index of the rightmost 0 you pick up in the subset should be smaller than the index of the leftmost 1 you pick up in that subset. Or in the other way, in the other words, we can say that you want to find out longest non-decreasing subsequence. Longest non-decreasing subsequence. In simple words, you just want to find out this thing. And finding out this is not difficult. So whatever longest non-decreasing subsequence you find out, its size would be put up here. So your final answer would be nothing but 2 into n minus the size of the largest possible non-decreasing subsequence, which we are calling as k for now. Size of largest non-decreasing subsequence. So for solving the problem, the tricky part was to realize this, in my opinion. Like, in my opinion, till this part, everything was very simple. Just doing some hit and trial of taking ones and zeros. After that, even taking the case of alternative zeros and ones was not a difficult thing to think. And this is also a natural thing. And thinking in this way is also natural, I think. And after that, the tricky part here was to realize that if you're having a rate, a larger value of rate, and a smaller value with a smaller green value, basically if you're having a pair like 1 0 anywhere, where 1 comes on the left side and 0 comes on the right side, then no matter whether you place the red item first or the red item later on, they will definitely cause trouble. The one coming up later on would have to be bought two times. So why not we just exclude it? Why not we just try to find out? Uh, okay, let me show you one more thing. The intuition from where you could have got the idea of picking up only a subset of these items is like, let's say if you have maybe let's say you have eight items, sort of like 0 1 0 0 1 1 1 0. So okay, let me give you colors. 0 0 0 1 1 1 1. Yeah, so if you have, let's say, this as the B array, then in that case the two strategies we had uh, got in our mind won't work here, because if you place the elements like placing the red elements first, the red elements here are 1 3 4 and 8, and the green elements here are 2 5 6 7, 2 5 6 7. So if you decide to place it like 8 4 3 1 2 5 6 7, or if you decide to place them as 2 5 6 7 8 4 3 1, in both these cases, like because of this 8 you would have trouble for these three people, and in the other case because of this 2 you would have trouble for these three people. So you would have three items to be bought two times, and here as well you will have three items which have to be bought two times. So basically your answer should come here to be 11, है ना? You should have 11 as answer, that you will buy 1 2 3 4 5 people one time. Actually, it's even worse. Even for this guy, will have to buy it twice. So you will have four people who have to be bought once and four people who have to be bought twice. है ना? And in this case, you will have four people who have to be bought one time, and then three people who have to be bought twice, and then one guy who has to be bought only once. So there would be 11 copies to be bought. है ना? The thing is, because of this one, because of this 2, है ना, with this one here, you are having three people. There are three copies which have to be bought twice. But if instead of this 2 here, if you had, let's say, placed it here, let's say you had bought this 2 at the end after buying all these others, then you will buy this once, 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 and only this guy would be troublesome for you, है ना? And yeah, sorry, 8 is still troublesome. 8 is still troublesome. So you will buy this guy once, this guy once, this guy once, this guy twice, this guy once, this guy once, 1 and 2. So this comes up to be like 10. है ना? You can actually get a better answer in this case by excluding some ones here. So this was the case which I could not identify during the contest, and that's why I was not able to solve it. But later on I absolved it, and this was the tricky part which I had missed, that uh, why don't we just find out the largest subset where we are not having any problems, we are just having the maximum red being smaller. So that thing would make sure that you will have as many people, as many items as possible to be bought with only one copy, and it would automatically reduce the number of items which have to be bought twice. So that's it for this problem. The code is pretty simple. You just have to find out the LIS. And yeah, currently we have discussed the solution for the complete array, but it is not difficult to find out the LIS of the first subarray, then second, then third, then fourth, and then fifth, sixth, and so on. Basically, you can just iterate from left to right and add one element one by one. So for each and every iteration, you would always be able to know about the current length of the LIS. Um, you must have solved a problem of uh, find longest increasing or non-decreasing subsequence uh, in n log n, in big O of n log n. If you have not solved this problem, just search it up internet and solve it first, and then look at the code. And either you can search for longest increasing or non-decreasing. The code would be just only one line would be different, everything else would be the same. So what we do here is we go from left to right in the array. Actually, yeah, we are taking the inputs one by one for each and every iteration, and then we find out the upper bound of that element in the array, and then if it is the end, then push back in the array, otherwise just update the value of the array as we do in this approach. Like if you have solved this problem, then you would know about what is happening here. After that, for every iteration, I'm just printing the answer as 2 into I plus 1 minus lis dot size. So here I is the index of the element which we are talking about. So in zero based indexing, this is the ith item in zero based indexing. So in one based indexing, or basically from index 0 till index I, there are a total of I plus 1 items. So that is why I'm saying 2 into I plus 1 minus lis dot size. For the subarray from 0 to I, this would be the length of the array subarray, and this should be the answer for each and every prefix for each and every I. And yeah, that's it. So that's it for this video. Thank you for watching the video, and bye bye.